So welcome to the video I'm going to produce for an introduction to differential equations from Calc 2 students. All right, so we're going to look at certain types of differential equations. And the beginning, what we're going to look at is just some terminology. So first of all, when you have a differential equation, you've got a derivative in there somewhere. So here's a second derivative, here's a first derivative, here's a first derivative. A little bit of terminology. This one right here, since the highest order of the derivative is the second derivative, we call this a second order differential equation. And for this instance, this one, the highest order derivative is a first derivative, so we call that a first order differential equation. All right. Now, one thing that you're doing in a equation, a differential equation, is you're finding a function. Instead of looking for a number for the unknown variable x, you're looking for a function. So the solution to this differential equation is going to be some sort of a function. All right. So what we're going to do to begin with is just work with some basic differential equations and looking at how we can determine if something is a solution or not. All right, so let's go down to this example 1, and the differential equation is this thing. That's a first order differential equation. Okay, so I'm going to just start by writing that down. This is just saying the first derivative of y with respect to t plus 5 times y is equal to 0. So we're finding a function that satisfies that problem. Okay, so what I've given you on this is a potential solution. We're going to see if this is the solution to the differential equation. All right, so what you want to do is we want to start by doing the derivative of this potential solution. Okay, so let's just go ahead and we'll do y prime of t. Okay, so that's an arbitrary constant, so we write that down. By the chain rule, the derivative of e to the negative 5 is e to the negative 5t itself, times the derivative of the exponent, which would be negative 5. Okay, so we end up getting the derivative, first derivative is negative 5 times the constant c times e to the negative 5t. So that's where you want to start the problem, is just doing that and getting that derivative done. Okay, so the second thing, now we're just going to plug everything in. All right, so y prime of t is going to be this thing. So we're going to plug that in like that. Okay, and then the second part of the equation, we have 5y. Okay, so y is what you're given. So it's this thing right here. And we'll see if that's equal to 0. Okay, so plug it in. Okay, y prime of t is negative 5c e to the negative 5t. Okay, plug in the y. So the y is this thing. So that is c e to the negative 5t, and notice on this that will be 0. Okay, so we have the same thing, a negative 5 and a plus 5, so that becomes 0. So that checks and verifies that that is a solution. Okay, and notice that that is a function. All right, so that satisfies the differential equation. Okay, let's try this next one here, and this one, we have a second order differential equation since we have the second derivative. And so that's the differential equation. The potential solution is this thing right here. All right. So again, what we typically do is let's start by finding the second derivative of this function. Okay, so we got y equals c1 sine 4t plus c2 cosine 4t. So let's do the first derivative. Okay, so the first derivative with respect to t is going to be c1 as a constant. The derivative of the sine we know is the cosine. So the chain rule, you would have cosine of 4t times the derivative of 4t would be 4. Okay, then you go to the next part. We know the derivative of cosine is negative sine. So that's c2 times negative sine 4t. And the derivative of 4t is 4. Okay, so I'm going to write one more step and just kind of clean that up a little bit. So this is 4c1 cosine 4t minus 4 C2 sine 4t, like that. All right, now we need to move on to the second derivative. Okay, so second derivative, we want to do the derivative of this part. 4c1 is a constant. Derivative of the cosine is the negative sign. So that'll be negative sine 4t. Chain rule says differentiate the 4t to get 4. Next part, we have minus 4c2. The derivative of the sine is the cosine. So that'd be cosine 4t times 4 by the chain rule. Okay, so I'll clean this up a little bit. And it looks like what we're going to have here is negative 16 c1 sine 4t. And here we're going to have minus 16 c2 cosine 4t, like that. All right, so we start by doing the second derivative. And then the second step is we're going to plug into the differential equation and see if it checks. Okay, so the differential equation is second derivative of y plus 16 times the function y equals 0. All right, so what we're going to do is this. The second derivative is this thing, so we're going to plug that in. The y is the function that we're trying to check, so that's going to plug in right there. All right, so what we have is we have negative 16c1 sine 4t minus 16c2 cosine 4t plus 16 times the function c1 sine 4t plus c2 cosine 4t. All right, let's see what we get here. So this is just bring this down. That's negative negative 16 c1 sine 4t minus 16 c2 cosine 4t. Then we can do the distributive property here to get plus 16 c1 sine 4t plus 16 c2 cosine 4t. And look what happens. How about this? All right. That goes to 0. That goes to 0. So it is indeed equal to 0. So that checks and verifies that differential equation. All right. So that's a good way to start learning about any type of equation, is what a solution is and how to verify that it's a solution. All right. So I'll go to the next part here. And so what we're going to do on this is look at a little bit different situation. So if we have a differential equation that has initial conditions that specify the values of y and possibly the derivatives, then we get basically what we call an initial value problem. Okay, so if we put together these initial conditions, we get an initial value problem. So this is kind of what it looks like on a first order differential equation. Okay, here's your differential equation. This is your initial condition, which usually is just going to say y of some value is equal to some value. Okay, so in this particular example, this is your potential answer. Okay, that's what we're checking. Okay, so that's what we think might be the answer. We're just going to check on and verify on this again. And then this part right here, that's your differential equation. And that's a first order differential equation. And then this part right here is the initial condition. Okay, and what that initial condition allows us to do is generally find the value of the arbitrary constant c. So once we start solving specific types of differential equations, that's one of the things we'll use that for. Okay, so there's a couple of ways you can go about doing this problem. The first thing you can do is we really need to know these two things. All right, we need to know what y prime of t is, and we need to know, to find that, we're going to have to look at this initial condition there also. All right, so we just got to check these things, and we're checking them when y of 1 is equal to 5. So to begin with, what I would do is, let's go ahead and let's take our potential solution and write that down. And then let's find y prime of t. Okay, so we got to do the first derivative. because the differential equation has the first derivative in it. So that is going to be just 48 t to the fifth power. So that's what's going to get plugged in for y prime of t. Okay, but what we want to do on this too here is we want to work with this condition y of 1 is equal to 5. All right, so let's go ahead and let's do this then. Do something real quick here. Okay, so what we have here is the initial condition. This is giving you the variable t. So t is equal to 1, y is equal to 5. All right, so what we're going to do on this is, let's just do these parts of the problem then. We're going to do this part, y prime of 1. So if we do y prime of 1, we plug in 1 into this derivative. So that's 48 times 1 to the fifth. So y prime of 1 is equal to 48. Okay, and then we want to do, we already got y of 1 is equal to 5. So now we're ready to plug everything in to finish this up. So what you want to do is you want to write down your differential equation. And now we're going to plug everything in. All right, so t is 1 because that's given from the initial condition. Y prime of 1 is going to be 48. So that becomes the 48 there. Okay, and then y of 1 right here is going to be, that's something that we were given. We were given that y of 1 is equal to 5, so that plugs in there. So that's what we're verifying. You just got to know that t is 1. That's given in the initial condition. You evaluate the derivative at 1 to get 48. And then y is just 5 when t is 1. So what we get is we get 1 times 48 minus 6 times 5. So that's equal to 48 minus 30. So that is indeed equal to 18. So that verifies that that's a solution to the differential equation, given that initial condition. Okay? All right, let's move down to this below here. This is just a little bit of definitions. I've already talked about this a little bit. So just terminology things. This would be a first order differential equation, again, because the highest order derivative is a first. This would be a second order and so forth. So you can have a third order and beyond like that. Okay, you study this in very in-depth when you study differential equations and differential equations classes. Here we introduce the idea and look at about 2 or 3 different types of differential equations. Okay, so on the next page, let's see, I'm going to do a couple of more of these things just where you check and verify. Then we'll get into learning how to solve a few situations. Okay, so on this one, let's see, here is your differential equation. Okay, that again is a first order differential equation. And then this part right here is your initial condition. Okay, so the way I like to start this is, well, if we're going to check this, hold on. Okay, we're solving this. I didn't put the directions on this, so I had to check that, okay? We're not checking anything. There's nothing to check, okay? So what we're going to do is we're going to solve this differential equation. All right, so let's start by just writing down the differential equation, y prime of t equals 3t to the second minus 4t plus 10. Okay, now what we're trying to do is we're trying to find the function y of t. So in order to find y of t, we have to integrate both sides of this equation. Okay, so we're going to integrate this side, and then we're going to integrate this side. With respect to t, both sides are integrated with respect to the variable t. Okay, so what happens if you integrate the derivative? Well, that would give you the function. So that gives that then. Now the way I'm going to do this then is just leave that like that. And then here I'm going to go through and just do this integral. It's a real simple integral. So that's 3t to the third over 3 minus 4t to the second over 2 plus 10t, and then you got to put your constant c in there. So what we would get is y of t is equal to t to the third minus 2t to the second plus 10t plus c. All right? So now what we do is the second thing is we use the initial condition to find the value of c. All right, so it goes kind of like this. What you want to do, I'm going to just write down our general solution. We call this the general solution of the differential equation. Okay, so we have this. All right, and this goes like this. So here is what t is, and then that's what y is. So what I'm going to do is that's going to be a 20. Then everywhere I see a t, I'm going to plug in a 0. Now this was one that's easy to do in your head, so you don't necessarily have to write all this stuff out. So what you would have is 20 equals just c. Okay, all those things would go to 0, so that means that arbitrary constant c. Okay, that's t is equal to 0. All right, so that means that the specific solution is going to be this then. We just put it all together. We know that c is 20, so the solution is y of t is equal to t to the third minus 2t to the second plus 10t plus 20. Okay, so that will be your solution to your differential equation. All right. Okay, so as we move to this next example here, we're going to do just a couple like this just to get the basic idea. All right, so let's take a look at this one then. Okay, so the first thing is, let's just write down, we have a first order differential equation. This is our differential equation. So let's just write that down. We have y prime of t is equal to 2t to the second plus 4 over t, and I'll put a dt there then, okay? Okay, so let's see. Let's go ahead and we're going to integrate both sides of this and see what we're getting ourselves into here. All right, so of course this is going to be y of t, and this type of integral right here, now we can do this in a couple of different ways. I would probably just separate. Okay, so let's just separate the variables or the fractions. So we'll have 2t to the second over t plus 4 over t and then dt. Okay, so we got a pretty simple integral here, looks like. So we have the integral of 2t plus 4 over t times dt. Okay, so that's the simplest way to put that together then. Okay, so now we can get our antiderivative. So this is going to be 2t to the second over 2, the power rule for integrals. This is a natural logarithm. So that's 4 times natural logarithm of absolute value of t. And then don't forget to put your plus c there. Okay, so our general solution, I'm going to write out the general solution, is going to be y of t, the function y of t, equals t to the second plus 4 ln of t plus c. Okay, so if the integration is simple, then these problems, there's nothing to it really. So now what we're going to do is get into this initial condition here. So the initial condition, again, allows us to find that arbitrary constant c. So I'm going to start by writing down our general solution. Okay, and then we need to plug in the values on this then. Okay, so basically when t is 1, so everywhere I see a t, I'm going to put in a 1. And the value of the function when it's evaluated is 2. Okay, so when I plug all this stuff in, what I get is I get 2 is equal to 1 to the second plus 4 times the natural logarithm of 1 plus c. Okay, so this is 2 equals 1. The logarithm of 1, that just means log base e of 1. So that's equal to 0, since e to the 0 is 1. Okay, so we get that plus c. So that's 2 is equal to 1 plus c. Therefore, c is equal to 1. Okay? So that means now what we do is we just put together and we get this specific solution, since we have found the arbitrary constant. So we'd have y of t is equal to t squared plus 4 ln absolute value of t plus 1. Okay? So that would be your solution, specific solution to that differential equation. Okay, so you're going to do some of these type of problems where you just have a function you integrate on both sides. Okay, that's the first type of differential equation. And generally, even in Calc 1, students learn how to do this. This may already look familiar to a lot of you. Okay, so I'm going to move to the next page, and I'll show you how to do a first-order linear differential equation. All right. So first of all, what you get on this is we're looking at kind of the form y prime of t equals like ay plus b. Okay, that looks like a linear equation. You're familiar with y equals mx plus b, so you can think of it having that same structure, except this is a first derivative. Okay, now there's a certain formula you use for this, and I'm going to go down here at the bottom and just kind of show you what this is. So here's how you get the solution to a linear first order differential equation. You actually have to use a formula. So this is the structure. You have a first derivative equals ky plus b. K and b are just real numbers. So the solution is this thing right here. All right. So that's actually all you got to do is use this. You got to identify, first of all, that it is a first order linear differential equation, and then you use this formula. You're going to find that when you study differential equations, there's a lot of formulas that you use when you start learning different types of differential equations. So this is generally a good starting point, is a linear first order. Okay, so here's the formula. I'll just kind of put that up here so you can refer to this as we go through these problems. Okay, so basically in here, the idea is, and again, if you go down and look at this, it's ky plus b. So I'm going to change what I wrote down to this. So this is how our book does. That's ky plus b. Okay. So in this particular problem, the first thing you do is just identify what you have. So k is going to be this number, and b is going to be that number. Okay. So what you end up getting is you get k is equal to 3, and b is equal to -4. Okay, then the second major thing that you do is you just go to this formula. So we have y is equal to the arbitrary constant c, e to the kt, minus b over k. All right, so c is the constant. Plug in k is 3, so we have 3t. b is -4, so we have minus -4 over 3. So that looks like the solution of our differential equation is y of t equals c e to the 3t plus 4/3. Okay, so that would be your solution to that linear first order differential equation. So you just got to know when you have that type of equation, then apply that formula. Now the third part is optional. I'm just going to check my answer. I think it's worth doing when you're learning any type of equation, be able to check and verify that you're right. So if you go back to the differential equation I gave you y prime of t is equal to 3y minus 4. So we need to do two things. We need to figure out what y prime is. We already know what y is. Y is our answer. So see, this thing right here is going to just be c e to the 3t plus 4/3. So we need to figure out what this derivative is. Okay, so let's do the derivative y prime of t. So we're doing the derivative of this thing. So that is just c e to the 3t times 3. That's it. So that would just give 3c e to the 3t. So that's what gets plugged in there. Oops, 3c e to the 3t. All right, so let's see what happens on this thing then. Did I miss something on here, didn't I? No, I'm good. I just was looking at this and I thought it wasn't going to check, but I see how it checks now. All right, so this is just 3c e to the 3t, 3 times y, so plug in the solution we got, which is c e to the 3t plus 4/3, and then minus 4. Okay, so just bring everything down. There's a couple of ways you can do this. Probably the simplest way is distribute. That'll give 3c e to the 3t. And then that will cancel the 3's out. You have 3 times 4/3 is plus 4. And then you still got the minus 4. So look at that. That is the right answer. Okay. So you have the power to tell that you're doing this correctly. All right. So the next one is just an initial condition problem. It's another example of a linear first order differential equation. And with this one again, we got y prime of t is equal to ky plus b, but we do have an initial condition on this problem now. And here's your solution. So I'll scroll up here, zoom on this so I can see what I'm doing. Okay, so with this one, what I'm going to do, now you can do this in a couple different ways. When I see this, u is in terms of x, so I'm going to rewrite this as u prime of x is equal to 2u plus 6, and then I'll put a du there. So I'm going to go ahead and I'm going to integrate that to start with, or not integrate that, but to use this thing, this formula, to solve that linear first order differential equation. So basically in this particular thing we have k is equal to 2, and then we have b is equal to 6. Okay, so by the formula we end up with, in this case it wouldn't be y, it would be u. Okay, so it would be u is equal to c e to the kt, so k is 2, and then it would be minus b, which is 6, over k, which is 2, so you would get u equals c e to the 2t minus 3. So that is what you would call your general solution. Okay, and then what you do is this initial condition, you use the initial condition to find what c is. Okay, so what this means, your variable is x here, so actually this just means x is equal to 1, and when x is equal to 1, then we get u is equal to 6. Okay, so that's a specific point. Okay, so what we're going to do is just plug into our general solution, which is u equals c e to the 2t minus 3. Okay, just replace u with 6. Replace, and that, you know what I did? That needs to be an x. Okay. So, I mean, you got to make sure your variables are right. So that's a 2x, like that. Okay, and let's see. We had x was equal to 1. So we have u is 6 when x is equal to 1. And that's enough information now to solve for c and find that constant. So we end up getting 6 equals c e to the second minus 3. Okay. So we have that, and then we're going to solve for c. Okay, so I'll just move the 3 over to this side, so I get 6 plus 3 equals c e to the second. Then I can divide by e to the second, so I get c is equal to 9 over e to the second. Okay, so now I'm ready to just put the answer together. So the general solution was u equals c e to the 2x minus 3, but c is equal to this constant. So that gives us a specific solution. So we'll just write 9 over e squared times e to the 2x minus 3. Now you could do a little algebra with this also. So what I see is you could write this as 9 e to the 2x minus 2, because you can subtract the exponent. That's no different than having like x to the 7th over x to the 5th is x to the 2nd. Okay, so you can do that, and then minus 3. Okay, that'd be the best way to do that then, and just put it together like that, and then that would be a good general solution of your differential equation. Okay? All right. So that's how you want to do that. You just basically use the formula. You got to know when you are given a linear first order differential equation, its structure, and the formula for the solution. Okay? Okay, next thing we're going to do is look at what we call a separable differential equation. And this is just a specific type of differential equation where you can separate the variables in such a way that you can get, you know, this together and then the other function together like that. So if your variables were like y and x, you have the ability to get your y's on one side and the ability to get your x's on the other side. Okay, so it only happens on certain differential equations. So I'm going to do a couple of examples of this, of separable differential equations. Okay, so first of all with this one, see we have two variables. We have y and we have t. So you want to see, do we have the ability to get all the y's together on one side and all the t's together on the other side? Well, okay, let's see on this. There's a couple of ways you can do this. One way is just simply cross multiply. I mean, this is a proportion. Or you could, do this. You could multiply both sides by y and do that. And now you've got your y on this side. And then you could multiply both sides by dt to get rid of this. And then you've got everything taken care of, see. Okay, so what would happen is you would be left with the y's together and the t's together. So it's just as easy on this thing to just cross multiply. So you have y times dy, and then you got 3t to the second times dt like that. So if it's a separable differential equation, you want to get it written in that form like that then. Okay, so that's step one, is to separate the variables. Okay. Step two, since we have y dy equals 3t squared dt, then we're just going to integrate both sides. Okay, when we do this then. And then we got to solve for y. So in doing this, we're going to have, this would be y to the second over 2 plus, and I'm going to just do an arbitrary constant that I'm going to call c1. I just do a constant on each side, and then we'll move from here. So the next side is just going to be 3t to the third over 3, or you could do that in your head. You could tell that's t to the third. Then I'm going to say plus c2 like that. All right, so what I have is I have y squared over 2 plus c1 is equal to t to the third plus c2. So after you separate the variables, you integrate both sides, but now you have to solve for y. Okay, so step 3, we're going to do this, and you have to kind of watch how I handle the constant. That's the part of this problem sometimes students are a little shaky on when they learn this, so we're going to solve for y. Okay, so the first thing I'm going to do is I'm just going to move the c1 to this side. So I get y2 over 2 is equal to t to the third plus c2 minus c1. Okay, like that. Now what I'm going to do is I'm going to just sort of absorb these constants. Okay, so what I'm going to do on this, instead of having more than one constant, the idea here is, well, if you knew what C2 and C1 was, then you would just subtract them and you'd get one answer anyway. So what you can do is, anytime you're just doing a basic arithmetic with your constant, and that would be like adding, subtracting, multiplying, dividing, anything that's arithmetical, then you can absorb that constant. So what I'm going to do here is I'm just going to do, that's y squared over 2 equals t to the third, but I'm just going to do a c. So I'm just letting c equal c2 minus c1. Okay, so now what I can do from here is I've got y to the second over 2 equals t to the third plus c. So now what I want to do is I'm going to multiply both sides of this equation by 2 to get, trying to get y by itself. So I get y to the second equals, then I got this, so that is 2t to the third plus 2c, like that. Now notice this part right here. Okay, again, I said you don't have to write the 2c on that because 2c, since you're just doing arithmetic, you can just replace that with the same constant c if you want to. And you don't really even have to keep track of all this stuff. Just kind of do this in your head. If you're doing an arithmetic operation on c, you can just reabsorb it into one constant c. So I'm going to write this as y squared equals 2t to the third plus c. Okay? All right, now what I could do is one more step. So I know I need to do the square root of both sides. So I would get y here, and I'm going to write this as y of t equals, and then you would have plus or minus the square root of 2t to the third plus c. Okay, so that should be the general solution of that differential equation. And yeah, the c does have to be under that radical, but the whole thing could be absorbed. So what I did is c2 minus c1. If you have two constants with arithmetic, just put it into one constant. Same thing with 2c. Just put it in a constant. Okay? And then that would be your general solution of that equation. Okay, let's look at the next one here. So this one, we've got y prime of t is equal to e to the y over 2 times sine of t. So this is what I like to do. The first thing I like to do is we're going to separate the variables. Excuse me, that's why we call this a separable differential equation. So what I like to do is I like to write this as dy over dt. Okay, then this side I'm going to have e to the y over 2 times sine of t. So we need to see if this is separable. So we need to get the y's together and the t's together. So the way you could do this, if you multiply both sides by 1 over e to the y over 2, well, what that'll do is that'll get your y's together. And then if we want to get rid of that dt, we can multiply both sides by dt to get rid of that. And then we've got everything separated, see? Okay, so what we're left with is dy over e to the y over 2, and then we're left with sine t dt. Okay, so let's just write what we have now. So we have this, and I'm going to write this as e to the negative y over 2 times dy is equal to the sine of t times dt. Okay, so that's the first thing, is we separate the variables. Okay, and one thing I recommend is, write that y prime as dy over dt. All right. So now we're ready to integrate both sides. So we have the integral of e to the, and I'm going to write this as negative 1/2 y dy is equal to the integral of the sine of t times dt. Okay? All right, so we know a formula for this. There's a kind of a general integral formula. The integral of e to the kx dx is 1 over k e to the kx plus c. So I'm going to do this. This is going to be 1 over that constant times e to the negative 1/2 y. And then I'll put a plus c1 there. Okay, and then of course you can simplify the complex fraction. And then we know that the integral of the sine of t is negative cosine t. Then I'll put a plus c2 there like that. So you want to get both sides integrated. Okay, so let's just simplify this. This will be negative 2 e to the negative 1/2 y plus c1 is equal to negative cosine t plus c2. So after you've integrated both sides, then you want to move into solving the equation for y, and you want to be pretty clear on how I absorb the constant. That's the part that's sometimes a little confusing to students. Okay, so let's see. First thing I'm going to do is I'm just going to move the c1 to the other side. So I get negative 2 e to the, and I'm going to take that back to negative y over 2, equals negative cosine t plus c2 minus c1. So just like the last problem, see this thing right here, you're just doing an arithmetic operation on two arbitrary constants, so you can absorb that into one constant. Okay? So I'm going to just write that right now as negative 2 e to the negative y over 2 equals negative cosine t plus c. Okay, like that. So now what I'm going to do is I'm going to divide by 2, or divide by negative 2. Now I'm going to do this like this. I'm going to do that like that also. Okay. So what I end up getting is I get e to the negative y over 2. And let's see, I'll write this as, we'll just say 1/2 cosine t. Okay, now look at this thing right here. See, I'm doing an arithmetic operation again. So you can have that c over negative 2, and you just absorb it into one constant. If it's an arithmetic operation, you can just absorb it into 1c like that. Okay? Then what we have from here is we can do solve the equation. We can do a log of both sides. Okay, so I'm just going to do this. Okay, so that's going to give negative y over 2 ln e equals ln 1/2 cosine t plus c, like that. All right, now what I'm going to do here is, of course, the log of e is 1. So I'm just going to multiply both sides by negative 2. Okay, and then that'll get y by itself, so we have y equals negative 2 ln 1/2 cosine t plus c. Okay, so you've got that absorbed into one constant. Now, it's important where it is. Okay, that needs to be within the parentheses like that. So that would be how you would write that answer. Okay? All right, so see, the thing on this is the reason I can't further absorb that is because cosine t has a variable in it. That's not a constant. So there's not just a simple arithmetic operation being done on that c. So that's as far as you could go with that then. Okay, all right, so the last one. Now this one, let's see what we got going on here. We have dy over dt equals ty plus 2. Okay, so what's going to happen on this is we got to figure out a way to separate the variables. Okay, well this is a little weird on this one. So like if I started off by multiplying both sides by dt, I would end up getting dy equals ty dt plus 2 dt. Well, so we're starting to run into a problem here. I got to get this y over here. Okay, well that's kind of problematic. Just getting that one y over there with this extra term there, you're not going to be able to do that. So this is non-separable. So we're not going to solve this one at this stage. All right, that would be more of a type of problem that you would look at in a differential equations class. So just for this level, you want to know that that's not separable. Okay, so that's the idea. Okay, so that'll wrap us up there. Differential equations they're generally not that bad in Calc 2 because the integrals are pretty straightforward. You've done a lot harder integrals than you saw me do on this video here. All right, so good luck. Have fun solving differential equations. Let me know if you have questions.